Hello class. Now in this lecture we will see the other thermodynamic term used for the processes or thermodynamic system, that is cycle. Okay. So till here we have completed the term like state, the term like process, the term like path. Now what is a cycle? So by the definition, the cycle is nothing but it is defined as a process or combination of processes. So conducted that initial and final state of the system are the same. Initial and the final state of the system are same. Or in simple word, if we define it or describe it, then more than two processes are come together. More than one processes are come together and form a closed loop. Here, state one and state two. These are the two states. In between these two states, okay, we can have transformation with the help of the process. State 1 can change to state 2, and state 2, from state 2 we can change our system transform from state 1. I mean to say our system can transform from state 1 to state 2 or from state 2 to state 1. This transformation is called as a process. Okay, so whenever system are transformed from state 1 to state 2, this is a one process. And when again system come back to initial state from state 2 to state 1 via this way, so it will form a closed loop, and this is called as a cycle. Okay, so here I shown you a cycle. One simple example here I tell you. Okay, so consider this is our piston cylinder assembly, which having one small hole at the top. Okay, so it is just an example of a syringe, that injection syringe you are using for the medical purpose. Okay, so that example I have quoted over here. So consider here, so here the piston cylinder arrangement are shown, which having a hole at the top. So it is an open system, as a control mass system is not there. System is open to atmosphere, so it's a open system. Okay, so consider here the system is at state 1 initially, so it is right here. Okay, whenever the things are moved downward side, means the piston move a downward side, then what will happen? A vacuum will generate or vacuum will initiate inside the cylinder. Okay, whenever this piston supposed to move, whenever this piston are supposed to move in downward direction, okay, that time if it move in downward direction, okay, that time what will happen? This thing when move downward direction, that time at this region vacuum will initiate, and this vacuum get responsible to suck atmospheric air inside the system through this tiny hole. Okay, whenever this piston move in downward direction, that time vacuum will initiate at this region, or negative pressure or suction pressure will initiate at this region, and that's negative pressure get responsible, or it is responsible to attract or suck of atmospheric air inside the system through this tiny hole. So for the sake of time, the system responsible to generate a negative pressure inside the boundary. Okay, and it will travel from state 1 to state 2. This transformation take place state 1 to state 2, and this is a process called a suction process. So that's why during the suction process a pressure goes beyond atmospheric pressure, means suction pressure, is it? Okay, and by following this path, by following this path, While transforming a system from state 1 to state 2, it follow this way. Here the pressure always less than atmospheric, okay, because during the suction atmospheric the pressure generated inside the system but obviously less than the atmosphere. So definitely it will follow a negative curve. This is negative curve. Why negative curve? Because this curve is below this atmospheric line, so it is a negative pressure and it will reaches to state 2, okay, and again it at the point of the atmospheric pressure means gradually negative, and after that it again travel towards the positive pressure, that is atmospheric pressure, and whenever system reaches to state 2 the atmospheric pressure will be there. Okay, at initially before the process starting there was an atmospheric pressure, and at the end of the process there is atmospheric pressure, okay, but in between transformation, okay, the thing is that negative pressure is there, okay. So this is a thing called as a one process. Now whenever system whenever system travel state 2 to state 1 means now it start to move in upward direction, okay. That time what will happen, whatever the air present here we try to push it out from this tiny hole, okay. We are trying to push it those air from this tiny hole to the atmosphere. So as this hole is very tiny, it will create a resistant force on this piston, okay. It won't easily escape out from the tiny hole, it create a resistance, okay, and it will responsible to generate somewhat more pressure than the atmosphere inside the boundary. So that's why whenever system traveling from state 2 to state 1, that time we are getting this curve somewhat more atmospheric pressure, having somewhat more pressure than the atmosphere. So this is a positive curve we will face. So whenever system traveling from state 2 to state 1, we are getting the positive pressure more than the atmospheric pressure, as that molecule are resisting their flow out through this tiny hole. So it creates a positive pressure and it represented by this positive curve, and it reaches to state 1 whenever piston completely reaches to state 1. So here state 2 to state 2. This is another process. So this is process called as a suction process, and this is a exhaust process. So this process completes a one cycle. Means see, your system working started its process from state 1 to state 2, and in second process again come back to initial state and it form a closed loop. So this is called as a cyclic process. It is called as a cyclic process. If our system started to state 1 and reaches to state 2 and it won't come back to initial state 1, then we can't call it as a cyclic process. It is just a process then, okay. But system come back to initial state after that it reaches to final state. Whenever system coming to the initial state, whenever it reaches to final state, then such a process is called as a cyclic process. We will see another example, okay. We will see the another example, okay. So okay, in the previous example we have seen this in the previous lecture we have gone through the example in which I told you, if in the first process I have removed those weight one by one slowly, okay, that time a system or that piston will move from state 1 to state 2, okay. So boundary shifting from state 1 to state 2, or we can say boundary expanding from state 1 to state 2, okay, with respect to means volume also increasing, okay. So this is a thing, boundary with expanding, or means volume is expanding from state 1 to state 2, okay, and pressure goes on dropping because it having the high pressure. As soon as I'm removing the weight from this on from that surface, then what will happen, pressure inside the gas supposed to relieve, and it will goes on decreasing with respect to increasing volume. So here volume is increasing and pressure goes on decreasing by path A. Okay, and now I supposed to add those weight again. Okay, then what will happen? Volume goes on decreasing and pressure built up on gas increasing. It again come back to process 1. So suppose in the first process system travel by path A, and in second process system travel by return by path C. So this will be your cycle. Okay, so this is the thing, means this is the first process, that is called as a expansion. As I remove the weight, it's supposed to expand, and second process I supposed to add a weight, then again system get compressed. Okay, in that time system again moving from state to state 2 to state 1, and this gas get again compressed by adding the weight further. Okay, so this is another example. So this become a cycle. Okay, so I hope you have understood the cycle, the meaning of cycle. Okay, now we will move further. Here the point function. Now what is a point function? Previously we have uh, understood, in the previous lecture we gone through the one of the thermodynamic term, that is state. Okay, so each state define a one point. Okay, in this cycle this is state 1 and this is state 2, so it represent a point. These 2 point or two state are joined by n number of lines or n number of processes. In between these 2 point, we can travel by path A, we can travel by path B, we can travel by path C. Okay, but in if I travel along this path A, then along the path A also there are number of points, number of states. For example, this is a one state, this is another state, this is another state, this is another state. Okay, so this is a number of micro state in between two initial and final state. Okay, but those state are having a absolute value, each microstate having their absolute value. Okay, so point function are such a function or such a property, we also call, in previous slide, previous lecture we have seen property. Okay, the thing which used to describe a system. There are two kind of property: intensive property and extensive property. Now all the property are not a point function, or all the property are not a path function. Okay, so there are some property are a point function, there are some property are a path function, and those property, we can't say. Okay, uh, always the difference of two path function is also path function. This is another thing we will see later, but just for sake of time, understood, just understand what is the meaning of the path function, oh sorry, point function. So here point function, it is such a property of system has a single value at each state, or it is such a property of system which depends upon the state of system and independent on the path selected to the complete the process. Okay, so here this is a state, this is a state 2. Okay, this is a state number 1, this is a state number 2, or we can say this is the initial state and the final state. In between state 1 and state 2, okay, if I ask you what is the pressure at state 1, then you can say it is a pressure respect to this point, that is P1 will be the pressure at point 1. I ask you what is the volume of the state 1, then you will say the volume respect to this point, that is called as a V1 will be the volume at state 1. If I ask you what is the pressure at state 2, then you will tell me The pressure respect to this point will be P2 will be the pressure at point 2 or state 2. If I ask you what is a volume at state 2, then you will tell me this is a volume at state 2. Okay, so in between state 1 and state 2, I can travel by path A also, I can travel by path B also, I can travel by path C also. But whenever I'm traveling through path A, B, C, the value of P1, V1, the value of P2, V2 is not changing. It's not depend on path whether you're following this process along path A, if you following this process along path B, or if you follow this process along path C. It doesn't matter. The volume and the pressure remain fixed. Okay, it remains fixed. It will be if you travel through path A, it will remain as P1 V1. If you travel path A, then it remain as P2 P2, by B also, by C also. So these property, it is such a property or such a characteristic of system which does not depend on path followed by system to complete that process. Okay, so that path may be that process may be isothermal, that means constant temperature process, constant pressure process, or constant volume process. It doesn't matter. Through constant temperature process also, constant volume process also, constant pressure process also, the state will remain same. Those characteristics are called as a state function. Okay, so there are state function. Another example of state function are enthalpy, volume we have seen, entropy, pressure we have seen, and the temperature, so on, are the point function. Now what are the path function? So path function are such a property which are depend on the path. If you are using path A, then it may be different. Okay, if you following path B, it may be different. If you follow path C, it may be different. In between same initial and final state, in between same initial and final state, 1 and 2, if you have two in a state of system 1 and 2, then system changes their state from 1 to 2 by path A also, by path B also, by path C also. But those property are depend those thermodynamic quantity which are depend on path follow between the two end state of the process and independent on the two end state are called as a point function. Means it is not depend on point, it is not depend on initial and final state, it is depend on path. Okay, so if I'm using uh, the path A for transformation of system from state 1 to state 2, I will have a different value of that characteristic. I will have a different value by path B. I will have a value different value by C. It is simple. For example, if I want to if I want to travel Nagpur to Mumbai, okay, my end path is fixed. Nagpur here and Mumbai here. But I can travel Nagpur to Mumbai by Nashik also. I can travel Nagpur to Mumbai by Pune also. Okay. I can travel by Nagpur to Mumbai by other way also. Okay. So path is different. So whenever I'm traveling Nagpur to Mumbai by path A, my fuel requirement is different. I will consume more fuel. If I travel in Nagpur to Mumbai by Pune, my fuel requirement is different, and some shortest way I've used to travel Nagpur to Mumbai, then it is fuel quantity is different. So similarly, in case of the thermodynamic system also, okay, we are selected a more efficient process to travel in between two end state, initial and the final state. If your system, that is machine, is power developing machine like IC engine, then we are trying to design or select such a process, or we try to select such a process. In that way you are getting a maximum power output. If your device is power consuming, like washing machine are consuming the power electricity, then we are trying to divide, design or select such a such a process in which your washing machine will consume a less power. The same way the processes depend how you are traveling from end state, in between end state. So this is path function which is depend on the path you have selected in between two end state for the transformation. Okay. Now here in our thermodynamics, heat, energy and work are the are the path function. Okay, those are the path function which is not depend on a path. Sorry, which is depend on a path. Sorry, it is a depend on a path. It is not depend on the end state. So here I have quoted note over here. So derivation of point function is exact differential. Hence, while taking a derivative of point function, so as a volume pressure, it is represented as a dv by dx, dp by dx. So here, derivative of point functions are perfect or exact derivative. Okay, but derivative of path function are inexact differential. Okay, it's a partial derivative because heat and work are one of the path function which are not only depend on only one character, it is depend on a number of parameters. So we can't take it's of exact differentiation for work and heat. So for always we can represent work and heat by partial derivative of q with respect to dx, partial derivative of work with respect to dx, del q by dx and del w by dx, because a path function. Okay, so how it will become a path function I will tell you in next slide or next lecture. Thank you.